Hello, my name is MOHAMAD bin RASHID. My entry number is 201332019, and I want to present about my parts. For my part, the beam I calculated is beam 3BC and beam A23. The column I calculated is A3 and the first part of connection timber. For beam A23, the section type is 457x191x161, the steel grade S275, and the length is 7 meter. The flange and weight classification is class 1. The design load for this beam is 8.687 kN per meter. The VED is 29.536 kN and MOHD 50.21 kN meter. The design check came out as satisfactory. For beam 3BC, the section and steel grade are the same as before, but the length is 11 meter. The flange and weight are both class 1. The design load for this beam is 14.68 kN per meter, VED 89.65 kN, and MOHD is 221.55 kN meter. The design check for VED and MOHD for this beam also came out as satisfactory. Next, for column A3, the section type used is 203x203x86. The steel grade also S275, and the length is 6.5 meter. The NAD for this column is 36.91 kN. The calculated moment distance from the axis is 0 km, and moment distance from y-axis is 6.235 km. The mean BRD for this column is 589.88 kN. The lateral torsional buckling resistance for this column is 184.31 kN per meter. All the value mentioned before are put into interaction equation for checking the section and come out as satisfactory. Lastly, for connection timber, plate thickness used is 35 mm, bolt size is 30 mm, and the bolt grade is 4.6. The direct shear Fs for connection is 0.94 kN. Shear due to torsion Ft is 2.57 kN. FVED or Fr for this is 2.94 kN. The shear resistance FVRD for one bolt came out as 107.71 kN, and the comparison for the resultant shear SVED compared to FVRD came out as satisfactory. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is HAZRIN bin HARUN. My metric number is 201332028. Today I want to continue my part for this mini project. Next is a part chosen. So the part that I choose is a column B3, beam B23, and tongue and groove floorboard for timber. Next we go to the beam B23. For the section type is 406 times 10178 times 85. For the steel grade is S275. So for the span length is a 6.8 meter. For the imposed load is a 4.0 kN meter square. Next we go to the detail of the sections. For depth is a 417.2 mm. For the width is a 181.9 mm. For the weight thickness is a 0.9 mm. For the flange thickness is a 18.2 mm, and the for fillet is 0.2 mm, and lastly for the mass is 85.3 kg per meter. So for the self weight of the beam is 0.84 kN per meter, and for the weight of the roof is 3.0 kN per meter. So the total for the permanent load is a 3.84 kN per meter, and the variable load is a 4.0 kN per meter, and for the design load is 11.18 kN per meter. So the section is satisfactory due to the design check is below 1.0, which is a 0.05, and for the moment buckling resistance is higher than moment bending, which is a moment bending total is 64.62 kN per meter, and for the moment buckling resistance is 342.54 kN per meter. Next, we go to the column B3. So the section type that I choose is 203 times 203 times 86, and the steel grade is S275. For the mass kN per meter, for the column B3 is 0.84, and for beam B23 is 0.84, and for the beam 3BC is 1.58. For the variable load is 4.0 kN per meter. So for the design load, beam B23 is 11.18 kN per meter, and for the beam 3BC is 14.68 kN per meter. Go to the column self-weight. The column self-weight is 9. Next, we go to the column self-weight. For the column self-weight is 9.64 kN. For the beam B23 is 38.01 kN, and for the beam 3BC is 80.77 at 7. Next, we go to the column self-weight. For the column self-weight, the total is 9.64 kN, and for the beam B23 is 38.01 kN, and for beam 3BC is 80.67 kN, and for the total NED is 128.32 kN. Next, we go to the nominal moment. For the nominal moment, at the y-axis is 8.02 kN per meter, and for the z-axis is 8.58 kN per meter. Next, we go to the interaction equation. So the section that I choose is satisfied due to the interaction equation. The total is below 1.0, which is 0.32. Next, we go to the tongue and groove floorboarding. So the center of temperature is 500 mm. For the brick wall span is 7.50 mm. The breadth of flow is 6.80 mm. Contact length of bearing is 100 mm, and strength class of timber that I choose is 6C16. So for the variable load is 4.0 kN per meter square. Timber service class also is 2. Next, we go to the self-weight. So the self-weight of tongue and groove floorboarding is 0.06. So for the permanent action is 0.06, same as the self-weight. And for the variable action, as I mentioned before, is 4.0 kN per meter square. And for the design load, for the tongue and groove floorboarding is 6.1 kN per meter square. Next, we go to the bending. For the bending is 0.12 kN per meter, and for the design bending strength is 14.1 Newton per millimeter square. So the tongue and groove boarding is adequate with respect to bending. So the H that I use is 13.0 millimeter. Next, we go to the permanent load deformation. The W total is 0.03, and the IY is 183.08 times 10 squared. So the total of the total deflection due to permanent action is 0.05. And go to the variable load deformation. The total W is 2.0 kN, and the total deflection due to variable action is 2.78 mm. So the total combined with the permanent and variable load deformation is 2.8 33 millimeter. For the limiting ratio is at 33.3 millimeter. So the tongue boarding is adequate with respect to the duration due to limiting ratio is higher than the total deflection. That's all from me. Thank you.
Assalamualaikum warahmatullahi. Nama saya Muhammad SYAFIQ bin RAHMAT, metric number 201332031. I will start the design for beam C/23. For the section design, I choose 457 multiplied by 191 and multiplied by 161. For this beam, design moment, to calculate design moment, surface at the beam plus flat roof, mean the top of the mall, and get the design look. The value is 12.183 kN per meter. For the moment diagram, MED, I got value is 70.42, and MED divided by FY is 256.07, which is smaller than 3780, which is okay for the design. And for yield strength, according to table 70, I follow from the EN 10025 to find FY. The F for this design is 32 mm and FY 275 Newton mm cos 2. And I will go through because this is I follow for English standard. For shear area, for the shear area, every web calculation, the value is 7,704 mm, and for the AV, the value is 9,067.2. The value is higher than 7,704, which mean we need to choose the higher, which 9,067.2, and then go for the design check. 0.03 is smaller than 1.0, and this section is satisfactory. Next, we go to the bending moment. The value for bending moment is 1039.5 kN meter, and design check 0.07 smaller than 1.0, and this is also satisfactory. Next, lateral torsional buckling LTB, because of M small is 0 kN, so the value of C1 is 1.88. 1.8 is okay. Next, we go to the MCR. For the MCR, the most of the value we need to check. We need to follow the universal bin or standard that are given. And for the value of MCR is 1867.53 multiplied by 10 or by 6 and millimeter. For non-dimensional cylinders is 0.75. And last is determine the buckling parameter. The value is 0.875. For reduction factor, the value is 0.76. And for the last, the value of MED need smaller than the value we got from moment buckling resistance. So For my MED, I got 70.4242, and the value moment buckling resistance is 775.63. So this section is satisfactory and it's okay. So this is for beam C2, C23, and for the beam, because I calculate the column B1, so column B1 bound with column B1 bound with 2 beams, so I need to calculate another beam to get the self weight for this beam to calculate the column B1. So this value is same for the value is same like the beam 3 BC and beam 2 BC. And then I go through for the column. For the column, steel design that I choose is 203 multiplied by 203 multiplied by 86. US grade is S275. For the design load, to calculate the external load, I need to plus all the 3 self weight, which is beam for the 2 beam and column itself. And the value is 131.7. For the load, for the nominal moment, load beam B12 is for 41.41 and load beam 1 BC 80.65. For the distributed moment, for nominal Y is the value is 8.74, and for nominal Z is 8.57. And then we go to the minimum buckling resistance. For the column slenderness, for Y axis is 0.924, and buckling strength for Y axis is 8,500 mm. For the column slenderness, Z axis, the value is 1.834, and column inflection factor from the table 6.2 in English Standard, for the curve B, Y axis is 0.34, and curve Z for the Y axis, Z axis is 0.49, and the reduction factor for Y axis is 1.2, and XY is the value is 0.56, which means smaller than 1.0, so we use 0.56. For Z axis, the value is 2.58 and 0.23, also smaller than 1.0, so we use 0.23. And we need to compare whether the Z and Y is smaller, then we need you to use the smaller value, which is 0.21. And we go for minimum buckling resistance. The value is 63,524. And we go for MCR. The value for MCR, we need to follow the design, steel design, column design for standard, and the value is 581.22 kN meter. For the column slenderness, the value is 0.677. The column impression for the column is use curve B, which is 0.34. Continue with section resistance. the value is 125.4 kNm, and for intersection equation we need to plus the 3 value from beam and column, and the value is 0.35, and this is smaller than 1.0, so this section is satisfactory. And I go for connection. I continue connection timber from calculation from HAZRIN. For the end bolt, the value is 0.52. For the inner bolt, the value is 1.04. And we go for bearing failure of bolt. The value is 0.52, should be smaller, and this should be smaller than 1.0, so it is okay. For K1, for each bolt, we use K1, the value is 2.5. For the inner bolt K1, use 2.5. For the bearing resistance of one bolt, the value is 412.8, which is bigger than 2.94. So this is okay. Bearing capacity of bolt is satisfactory. Therefore, 30 mm diameter of bolt of class grade 4.9 is satisfactory for connection. That's all for me. Thank you.
Okay, nama saya Muhammad bin SHA'ALAHUDDEEN. Saya akan menerangkan penyeraan bagi beam yang telah saya pilih, iaitu beam B12. Untuk section detail, section type yang telah saya pilih iaitu 457 x 191 x 161, steel grade S275. Ni maklumat mengenai section yang telah saya pilih. Untuk design moment, GK yang saya dapat adalah 4.58 kN per meter. Untuk GQK pula 4.0 yang telah diberi. Design load, saya mendapat 12.18 kN per meter. Moment diagram, VED saya dapat 41.41 kN, MED 70.40 kN per meter. Okay, untuk section classification, untuk flange saya dapat 8.28, jadi flange di kelas pertama. Web pula saya dapat 66.24, web juga berada di kelas pertama. Untuk shear area, AV web saya dapat 7704 mm squared. Untuk AV saya dapat 9067.2 mm squared. AV lagi besar dari AV web. Jadi design check saya dapat 0.03, lagi kecil daripada 1.0, jadi this section is satisfactory. Untuk bending moment pula saya dapat 1039.5 kN/m. Design check saya mendapat 0.27, dia dah kecil dari 1.0, jadi satisfactory. Seterusnya untuk electrical buckling moment, iaitu MCR. Pengiraan saya telah mendapat 1867.54 kN/m. Untuk non-dimensional slenderness, lambda lateral torsional saya dapat 0.75. Untuk determine the buckling parameter saya mendapat 0.87. So reduction factor saya dapat 0.76. Result terakhir saya mendapat OK, iaitu MED 70.40 kN/m, lebih kecil dari MBRD 79.02 kN/m. Jadi section is satisfactory. Bagi kolom, saya telah memilih kolom B2, section 203 x 203 x 86, UC in grade S275. Untuk analysis of external load. Kolom SYAFIQ 9.64 kN untuk beam yang berada berdekatan kolom, iaitu beam B23 38.01 kN, beam 2BC 80.72 kN, beam B12 41.41 kN, dan LED kolom B2 iaitu terdapat 169.78 kN. Untuk MBYED saya terdapat 0.72 kN/meter. MBZED saya dapat 8.58 kN/meter. Seterusnya distributed moment. Untuk MYED saya dapat 0.72 kN/meter, manakala MZED 8.58 kN/meter. Untuk kolom slenderness about YY axis saya dapat 86.8, manakala buckling length dia 8500 mm, lambda 1.055. Untuk kolom slenderness about ZZ axis, lambda nya saya dapat 1.834. Untuk kolom imperfection saya dapat 1.06, rendah dari 1.2. Seterusnya reduction factor Y axis saya dapat 1.20, lambda Y saya dapat 0.56, lagi rendah daripada 1.0. So lambda Y 0.56. Z axis saya dapat 2.58, lambda Z saya dapat 0.23. Jadi use lambda Z 0.23. Untuk minimum buckling resistance and min BRD saya dapat 695.75 kN. Untuk lateral resistance, buckling resistance, elastic critical moment MCR saya dapat 581.22 kN/meter. Untuk kolom slenderness LTB, lambda LT saya dapat 0.68, kolom imperfection saya dapat 1.06, rendah dari 1.2. Yang ini saya dapat perimeter LT saya dapat 0.72, lambda LT saya dapat 0.88, dia rendah dari 1.0. Lateral tensional buckling resistance MY BRD saya dapat 236.43 kN/meter. Section resistance MZ BRD saya dapat 125.4 kN/meter. Jadi interaction equation keseluruhannya saya dapat 0.381, lebih rendah dari 1.0. Jadi section is certified. Seterusnya untuk timber wall plate, saya telah menggunakan wall plate bersaiz 100 x 85. Untuk TD saya telah dapat 0.570. Untuk KV saya dapat 0.829. Bagi KN saya dapat 5.0. Jadi nilai yang saya dapat 8.160. So KV saya dapat 0.613, lagi kecil daripada 1.0. Untuk KV LVD saya dapat 0.748 Nm/mm². Jadi saya telah mendapat TD lagi kecil daripada TD lagi kecil daripada KV FVD. So dia akan dapat nilai OK. Joist is adequate with respect to shear.
For beam 2BC, the section detail is this, and width gauge of this, then the length of the design, the detail of beam, then the calculate of permanent load, variable load and design load for bending moment diagram, and then yet strength, which is flank and web, then shear resistance to get the class of flank and web, then calculate the AV. After that, calculate the VED to get a section certified or not. Then bending moment to get the certified or not. Then torsional buckling modified. Illustration critical buckling moment MCR. And last, check the moment buckling resistance MED not large than MBRD, which is can get okay. For column, which is C/3 designed by me, is assume size 203 and 86 in grade S275. This is the position. Then this is from above. So this is the member that include in this design. So first design total of NED, then nominal. After that, get the nominal Y and Z. Then destructive moment, minimum buckling resistance, and next reduction factor, then minimum buckling resistance, which is 635.25 kilonewton. Then MCR, which this is. Then the column slenderness, then lateral torsional buckling resistance. Then after that, the comparison of insertion equation section for certified okay or not. Next, for timber part B, first join at 5,500 mm center size width. Then got the FD total. Then calculate bending, which is MOHD. Then design based on selected dimension. Then try size beam until it's past the load. Then design bearing. Next, the service limit. For the design stress, it have to get the more large than design stress, which is this. Then service limit. Next, permanent load deformation, calculate for permanent and variable. Then then plus to get the total number of WFIN. Then comparison to limit ratio. After that, if it's more large than WFIN, it is pass.